Hello, Joyce. Hello, Lloyd. I think Lloyd is still. Lloyd did not come. Oh, uh, hi, Joyce. Hi, Lloyd. We're just. Oh, and Jasper's here. We're just gonna wait for 2 more minutes and see if more people come, and we'll start at 7:03. Hi, Jasper. We're just waiting for a few more minutes. Actually, it's time. So, all right, we're just gonna start now. Uh, okay. So today we'll be actually talking about geometric sequences and series. Now, I remember the last week we talked about arithmetic sequences and series. This week we'll talk about geometric sequences and series. These are actually pretty fundamentally similar, but geometric sequences and series are actually a lot more interesting than arithmetic. So let's start. So let's first start by defining what is a geometric sequence. As we covered in our arithmetic sequences class, if you remember, a sequence is an ordered list of numbers. A geometric sequence is a sequence in which each number is obtained by multiplying the previous number by a fixed constant. This fixed constant is called the common ratio of the sequence. So right now we've introduced an idea called the common ratio. And let's take a look at some of the geometric sequences. So here you can see that 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512 are all, in fact, geometric sequences. Why is that? Well, if you look at these numbers, these sequences of numbers, which is a list of numbers, a list of ordered numbers, you can see that going from 1 to 2, what do we multiply by? Jasper, what do we multiply 1 by to get 2? 2, really good. And let's look at the next one in the series. I mean the sequence. What the next number in the sequence is the next number in the sequence. The next number in the sequence is 4. What what is what number do we multiply 2 by to get 4? Joyce or Lloyd?
2.
It's 2. It's 2 again, right? So right now we're seeing a pattern, which is that we multiply each number in the sequence by a common number. In this case, it's 2 to get the next number in the list. If you don't trust me, you could try and do a few more examples. This one is 2. This one is 2. This one is 2 again, and this one is also 2. So a geometric sequence its definition might sound a little bit complex, but it's actually in reality very, very simple. I mean, you just multiply every number by a common number, which is called the common ratio of the sequence. So 2 here in this case is the common ratio because you multiply each number by 2 to get the next number in the list. So the common ratio is in fact 2. Let's look at the next sequence. 3, 6, sorry, 3, 6, 12, 24, 48, 96, and 192. Once we look at these numbers, we'll see that these numbers also have a similar trait as the last one. Now, who can tell me what is the common ratio of this sequence? So remember, the common ratio is a thing that you multiply each number by to get the next number in the sequence. And the first example, the common ratio is 2 because you multiply each number by 2 to get the next number in the list. So does anyone know what is the common ratio of the second sequence? Yes, Jasper said 2. That is, in fact, correct. Because if we look at the sequence, we'll see that for each time, we're multiplying by the number by 2 to get the next number in the sequence. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So essentially, we're just multiplying each number by 2 to get the next number in the list. Now, for the third one, it's slightly more challenging. Why? Well, because for the third one, we actually have negative numbers. That is pretty challenging, right? I mean, no one likes negative numbers. It's a really annoying thing that really messes up your mind. But unfortunately, negative numbers do exist in sequences. I mean, geometric sequences. And the worst thing is that it actually bounces back between being positive and being negative. Because if you think about it, by getting a geometric sequence, you're essentially multiplying by the same number every time. So say you have a positive number and you have a negative common ratio. Joyce, tell me what happens when you times a positive number by a negative number.
Becomes a positive. Wait, I don't know.
So positive times negative. Sorry. So positive times negative, it should be pretty straightforward because sorry, my device had a problem. So positive times negative, it should be in fact negative, right? Did you guys all see that? Joyce, Lloyd, did you guys all understand that? Positive times negative equals to negative. Have you guys learned that before? Nope. Oh, that's a bit unfortunate because it's oh, Jasper have. So let's talk about this briefly right now because we're gonna use this a lot and the questions in the later slides. So say we have a positive number, right? A positive number, and it's 1. What is 1 times negative 2, Joyce?
-2.
That is, in fact, correct. And you can see that 1 is a positive number, right? Negative 2 is a negative number. When you time up a positive number with a negative number, you get a negative number, which is in this case negative 2. And this for every other number of combinations. 2 times -2 is Lloyd, what do you think is 2 times -2?
-4.
That's great, Lloyd. It is in fact -4. So we see here again that a positive number times a negative number gives you a negative number. And so when we start with a 5 and we times it by a negative common ratio, we get a negative number. However, have you guys learned that when times a negative number by a negative number, it becomes a positive number? Joyce, Jasper, have you guys learned that when you times a negative number by a negative number, it turns into a positive? Yeah, it's really weird, but oh, Joyce, you learned that? Okay. So yeah, let me give you a quick example. So what is divided by -2? Well, normally you think it's 3, right? But if we use the rule before, -2 times 3, we just show that negative number times a positive number must equal a negative number, right? So for this one, it's actually going to be -6, right? No worries, Jasper. It's pretty complicated, I know, but right here we just proved that -2 times 3 can't equal to 6. So what must we need to time -2 by to get 6? Well, we need to add a negative sign in front of the 3 and turn it into a -3. -2 gives you a positive 6. That is pretty annoying, I know, but that's just how math works. And a simple way to remember this thing is that this is the negative sign, right? This is a negative sign. So what happens when you have two negative signs? You add them together, right? So here's one negative sign, a horizontal negative sign, and a vertical negative sign. That becomes a plus sign, right? So negative equals to positive. And that's just one thing we have to go over. So did you guys all understand that? Yeah? Oh, okay. Well, let's check some examples. So for this one right here, I was talking how having negative common ratios or just even negative numbers in geometric sequences can be extremely annoying because when times a positive number by negative numbers, it becomes a negative number, right? However, when you time a negative number by a positive number, by a negative number by a negative number, it turns back into a positive number. And when you times a positive number that you got by a negative number, it turns back into a negative number again. So the annoying thing about geometric sequences is that once you have one negative number involved, it starts to jump back and forth between positive numbers and negative numbers, which is quite annoying, right? I mean, look at all these signs you have to add, and it's going to be a lot more into a calculation. So for this thing right here, who can tell me what is the common ratio for the third one? Yes, Jasper said -3. That is in fact correct. The Jasper, can you explain how you got negative 3? So 5 times -3 equals to -15. -15 times -3 equals to 45, and so on. That is, in fact, correct. And it's incredible how you grasped an idea so fast. Well done, Jasper. It's really your mathematical ability is really good. So yeah, it is the common ratio here is -3. Can everyone see how did everyone get why the -3 is a common ratio? If so, I'm gonna move on. So let's see our first example. So what's the next term in the sequence? I'll give you guys 1 minute to figure out what is the next number in this sequence. 3, 9, 27, 81. Give you guys some time. No worries, Jasper. $323. That is, in fact, correct. Jasper, can you explain to us how you got that? Oh wait, no, Jasper. I think sorry. I think you you got something wrong here. I think you memorized your multiplication table incorrectly. 81. So for 81 times does 81 times 3 does not equal to 323. I think you times the 8 here by 4. Yeah, 220, 243. Did everyone see how Jasper got to that conclusion? All right, I'm going to explain this briefly. So when we're doing these kind of questions, do first find the common ratio. So we need to find the common ratio for this sequence. And when we look at the sequence, we can see that all of these numbers differed by a multiplication of 3, right? Because 3 times 9 is 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So it is clear that the common ratio is in fact 3. So what we need to do now is that to get the next number in the sequence, we times it by the same common ratio, because that's how the geometric sequence work. So as Jasper claimed, 81 times 3 is 243. And he is, in fact, correct. The next term in the sequence is, in fact, 243. Joyce, Loy, did you guys all get what just happened?
Yes.
All right, great. I'm going to move on to the next slide. Let's try a slightly more challenging question. So this time you have two numbers to fill in. Let's see if you guys can manage to solve this problem. I'll give you guys 1 minute. And feel free to type the answer in the chat when you're done. 108 and 972. That is in fact correct. Jasper, do you want to explain how you got to that conclusion? All right, I think Jasper is lagging a bit, so I'm just gonna go ahead and oh yes. So the sequence is Jasper just said the sequence is times 3. So uh we can in more professional terms, we can see that the common ratio here is 3, right? Right? Joyce, Lloyd, times 3 to get everything here. So to get the missing terms, we only need to time the former number by 3. So Joyce, what is 36 times 3?
18.
36.
Oh, wait. You said 6. I thought you said 6 times 3.
Oh, 36 times 3.
Oh.
So 36 times 3, which should be the next number in the sequence, is 108, right? So 108. So this number is 108. For 324, we times it by 3 yet again. And as Jasper said, the correct answer for 324 times 3 is 972. 324 times 3 equals to 972. So that is how we got the answer for these two questions. All right, let's move on to the next one. Consider the following sequence: 4, negative 16, 64, negative 256, 100, 1024, and so on and so forth. So for this one, it's a little bit tricky because it involves negative numbers, and I'm going to give you guys 1 minute to solve this question. Feel free to type the answer in the chat once you're done. All right, did anyone get the answer? No? Well, I'm gonna go ahead and solve this question for you. So from here, we can see that the first number is a positive number, and the second number is a negative number. So we know that the common ratio must be negative because or else we can't get a negative number by timesing a positive number by a positive number. So the common ratio has to be negative. And so let's see, what is the common ratio? So what is negative 16 divided by 4? Or in other words, what do we need to time 4 by to get negative 16? Joyce?
Eh,
Jasper is asking, can you times the 99th term by 99 times negative 3 and then adding 4? Well, that is in fact, I think you might be confusing that with their arithmetic sequence generalization equation that we did last class. This is a little bit different. But right now for this one, we're trying to figure out the common ratio for the sequence. What do you think is the common ratio for the sequence, Jasper? It's negative 4, and that is in fact correct because you times 4 by negative 4 to get you times 4 negative 4 to get negative 16. You times negative 16 by negative 4 to get 64, and so on and so forth. So for this one, the common ratio is in fact negative 4. And after we found out the common ratio, what we need to do is that we're for the nth term of this sequence, the first term is 4, right? So for the first term, we write down the first term, which is 4, and then we times it by negative 4, and we can see that we're timing it by negative 4 to the n minus 1 to n minus 1th power. Why is that? Well, it's rather simple because think about it. For the first one, you have 4, right? The first number in the sequence is 4. And you times it by negative 4 to get the next number in the sequence. But for the first one, it's just 4. So what we have right here, so this negative 4 shouldn't exist. And so what is 1 minus 1, guys? Zero, right? It's 0. It's really simple. It's 1 minus 1, and that's just 0. So here's a quick fact. Any number to the power of 0 equals to 1. So 4 times 1 equals to 4. And thus we get that the first term in the sequence is just simply 4. For the next number in the sequence, we have negative 16. And for the second number, n is 2. So we have 2 minus 1, and we have 1. So it's 4 times negative 4, which gives us negative 16. And so on and so forth. So the generalization, the nth term of the sequence is just 4 times negative 4 to the n minus 1th power. And so what is the 99th term of the sequence? Before we move on to this, did everyone get what I just did? All right, I'm gonna move on then. So since we got the generalization equation, n minus 1, we just plug in the number. So it's 4 times -4 to the 99 minus 1th power. And so to get the answer for this, we might need to use a calculator. Why -1? Jasper, that's a really good question. Well, because you see, for the sequence, the first number we have is 4, right? And the second number we have is -16. So essentially, we're multiplying each number by the common ratio to get the next number in the sequence, right? So firstly, we write down the first number in the sequence, which is 4, and then we write it. We times it by the common ratio, which is -4. So you can see that for each number in the sequence, we times it by -4, right? And then however, for the first one, we don't times it by anything, right? Because for the first one, it's just 4. It's not timed by anything. So right here, it needs to be n minus 1 because we only start multiplying it by the common ratio after we got to the second number. So the number should be 4. So this generalization equation should be 4 times -4 to the n minus 1th power. Yeah. That's why it's always -1. And so you guys want to use your calculators to calculate the answer for this thing? 4 times -4 to the 99 minus 1 power. So for this one, we get 4 times -4 to 99 minus 1 power, which is 4 times -4 to the 98th power. And when we times it by that, we get a really large number. And in fact, it's too big that I don't even know how to write it down, but it's just a really big number. And here's the generalization equation. And unfortunately, we have to end today's class right here. I mean, I really enjoyed teaching you guys, but today I'm having a little bit of a fever and I'm not really feeling that well. And I was supposed to get my partner. I was supposed to get my partner to finish the latter half of the class, but today he also has something that so he can't come to the class. So unfortunately, that's where the class ends today. But have a great weekend and enjoy math. Thank you guys. All right, thank you, Jasper.
Bye.
Bye. Joyce, do you have any questions?
Was kind of confusing, but you know what? It's fine.
You what?
It was kind of confusing, but it's fine.
Yeah, sorry. I'm not really feeling that well today. I mean, I'm having a fever right now, so I'm sorry if I didn't make the class that well. Sorry.
No, it's okay.
Have a great weekend.
Okay, goodbye.